In this video, we're going to talk about the relationship between polar and Cartesian coordinates. Okay, so the relationship is that, or the idea behind the relationship is you kind of want to think of the pole as being at the origin of the Cartesian coordinate system, right? So let's go here and let me clear this stuff off from a previous video. Okay, and so if I go back to the Cartesian coordinate system, right, and plot the point 0, 0, you can see it's at the origin, right? And here, if I switch then back to the polar coordinate system, right, this point, the point that was at the origin, is at the pole. So that's number one, right? You want to think about the origin in the Cartesian coordinate system where the x and y axes cross, right? That's at the same place as the pole would be in the Cartesian coordinate system. And then the other thing is if I switch back to the Cartesian coordinate system and look at this ray right here, the ray that goes in the direction of the positive x-axis that starts at the origin, right? That is going to be where the polar axis is located. So if I switch on over back to the polar coordinate system, you can see that is where that is along the polar axis right there. So that is how they are related to each other, okay? And so if I plot a point here, right, we have this point being plotted, and you can see it has the x and y axis from the rectangular coordinate system. It would have rectangular coordinates x and y, right? So what you can do is think about where would the r and the theta, right? What relationship would that have here? All right, and as we said, the r value, at least the absolute value of r, is the distance from the pole, right? And so we know that the pole is at the origin. So that means if I plot the point x, y in the Cartesian coordinate system, right, then the r value is going to be the distance from the pole. Now, you do have to be a little bit careful about whether that's negative or whatever, but we're just going to explain the basics of how this works with these points in the first quadrant. And then, you know, if it were down in another quadrant and have different representations, these relationships are still going to be valid, although it's a little bit harder to see. So I'll just stick with the simpler relationships here. Okay, so that's what R would be. We've already talked about the fact that the x-coordinate, right, is going to give you the distance from the y-axis. So that would be this distance right here. And we've already talked about that the y-coordinate would give you the distance from the x-coordinate right here. So what you wind up with is this little triangle. And it's important to think about that triangle here. So that triangle here has side length x, side length y, and over here side length r. And that forms a right triangle. So that's going to give us a nice relationship between x, y, and r using the Pythagorean theorem. Okay. Next up is theta, right? And theta is that angle that you would rotate through, right? And so that the terminal side is going through that point. And here you can see that theta, right, the second polar coordinate, right, of whatever this point is going to be an angle inside that right triangle here. Okay, so it's this relationship that we will use in order to come up with some techniques for switching back and forth between rectangular and polar coordinates. All right, in the next video, I will give some examples about how that is done and talk about the specifics of it.